Okay, so we're going to add and subtract rational expressions. The concept is the same whether you add or subtract the numerators. What's important is that we have to find a common denominator because if you remember, if you try to add or subtract fractions with a different denominator, if you recall that you would have to find a common denominator, which means make the denominators identical, and then add or subtract your numerators. So if you look at the denominator, 3p and 2p squared, those two denominators are not identical, so we can't do 4 minus 5. So we're going to have to find a common denominator between 3p and 2p squared. Let's start with the numericals, 3 and 2. Okay, in order to find a common denominator, it's also referred to as the least common denominator or least common multiple. Okay, so if you want to really find the common denominator, there are many ways. You can take the, the 3, and you can take the denominator 2, and you can literally count by multiples of these two individually, and you identify the number that appears in both rows first, and that gives you your common multiple or common denominator. So if you do 3, 6, 9, etc., 12, here you have 2, 4, 6, 8. And if you notice that what number appears in both rows first, or the smallest number that appears in both rows first, it's going to be 6. So therefore, 6 equals my least common denominator or least common multiple. Okay, so we need to do that first. And we need to look back, look at the denominator 3p. Okay, how do we make that a 6? Well, we're going to have to multiply it by a 2. But what you do to the denominator, you also have to times the numerator by that same quantity, because a fraction is a ratio. So if I'm doubling the bottom, I need to double the top as well. So whatever you multiply the denominator, just multiply it by the numerator as well, whether it be a variable or a number or both. Okay? And also, if you look at the variable, the variable here is p. Okay? P to the first power. Well, in order to make that looking like a p squared, okay, we're going to have to times it by a p. Okay, so we're going to have to times the top and bottom by p as well, because if you remember, p times p, if you add the individual exponents, okay, that equals p squared. That is the only way to get p squared is times it by p. So you have to be a little bit familiar with the rules of exponents, right? So that's why I'm multiplying the whole left fraction by 2p, top and bottom. If you look at the right fraction, it has the p squared, so you don't really need to change that, okay? What we do need to change is that 2. Again, we need to make it a 6, because we agreed that the common denominator is 6, numerically anyway. So we're going to have to times this right side by 3. And don't forget, we're going to do the top as well. So when we simplify this, okay, we're going to get 2p times 4. I'm just multiplying everything together here. So that's going to be 8p over 2p times 3p is going to be 6p squared, minus, and then 5 times 3 is going to be 15. 2p squared times 3 is 6p squared. You notice the common denominator is actually going to be really 6p squared. That's my common denominator for the fraction. Okay, so now that the denominators are identical, we can go ahead and write it as one fraction. So we're going to take the 8p and we're going to subtract it with 15, and we're going to write it under one denominator because these are identical, so we don't need them to be separate anymore. We can express it as one fraction and therefore do the operation that it's telling you to do, which is subtraction. So 8p minus 15. Now, why can we not subtract it? It's because 8p is a different term than 15. This is just a constant, which is just a number, and then this is a a numerical with a variable attached to it. So those are different terms. It's like apples and oranges. You know, you can't really combine them physically. So you have to leave it as 8p minus 15 over 6p squared. So this would be the final answer for that.